Hi viewers, welcome to my channel. This is Anthony Vijay. Today we are going to discuss about from the topic classical encryption technique. In this we will be going to discuss about two different techniques called Vigenère Cipher. The other one is One-Time Pad Cipher. So first of all we will be going to see about Vigenère Cipher. So the Vigenère Cipher is an old method. It is used to hide secret messages. It was created in the year of 1500 and it's the first cipher to use more than one shifting rule, unlike Caesar cipher, which shifts every letter by the same number. Vigenary uses it's like keyword. So this keyword helps decide how much to shift each letter, which makes the message harder to break. When I talk about features, it uses a keyword that repeats to match the message length. Each letter in the message moved by a different count based on the keyword. It is stronger than Caesar cipher and it is also called unbreakable cipher because it was so hard to solve. So in this example, I am going to take a plain text as attack at dawn and the keyword is 11. Let's see the encryption process. So here the first step for the encryption process is we have to repeat the keyword. Here the length of a keyword supposed to be matched with the plain text. So already the size of a keyword is just 5 only. So that we have to repeat the length of keyword until the size of plain text matches. So this is the first step. Then we have to convert the letter into numbers. As usual, we have to start A with 0 and B with 1 and end with 25. So we have to assign values for each letters. A equal to 0 and T equal to 19. Likewise, we are applying for plain text. After that, we have to apply for keyword 11. So L for 11 and E for 4, M for 12. Likewise, this process continues. Okay. So after this process, we have to add the plain text with the keyword. Let's see. So in this encryption process, we have to add the plain text with the keyword. And finally, we have to apply modular arithmetic 26. So as you know already, here the plain text is attack dawn and the values like this 0, 19, 919 like this. Okay. And for keyword, it is 11, 11 for 12. So we have to add 0 with 11. So 0 plus 11. 0 plus 11 is 11. So the cipher text will be L. Likewise, 19 plus 4, it is 23. So it is X. Again, 19 plus 12. 19 plus 12, it is 19 plus 12 is what? It is 31. If it is 19 plus 12, then we have to apply mod 26 on it. So here it is 31. 31 mod 26. It is what? 5. So the value for a character is F. So likewise, we have to repeat. When the value is more than 26, we have to apply mod 26 and we can do like this. Okay, this is what happening in the encryption. So this process will be repeating. So finally, we got LXFOP VFR NHR. This is the encryption text. Okay, let's see the decryption part. In the decryption part, we have to subtract the cipher text with the keyword. And if any of the value is getting minus, we have to add with 26. Otherwise, we no need to add with 26. And finally, we have to apply modular 26. Let's see the first step. Again, we have to repeat the keyword. So as of now, we got the cipher text LXFOP VFR NHR. This is the cipher text. And once again, we are applying the keyword only here. And we are repeating the keyword like this. And we have to convert the letters into numbers like this. Again, A equal to 0 and still Z equal to 25. And we are assigning a value like this. For L, it is 11. This is for cipher text. Okay. And X 23 F5. Likewise, we have to assign. We have to assign value for each character based on a table formed by letter to numbers. So this is what the next step. And the third step is decryption formula we are applying. That is cipher text minus key plus 26, then mod 26. As I told already, this plus 26 is only applicable when we get negative values. okay, otherwise we don't want this. Okay, so here we are taking only the cipher values and key values. So 11 minus 11, it is 0. So if it is less than 26, no need to add 26 here. So 0 means the value for 0 is, that is A. This is what process we have to do. And for 23 minus 4, it is 19. And for 5 minus 12, see here, 5 minus 12, 5 minus 12 is minus 7. So minus 7 plus 26, it is 19. So in this particular area, we have to add 26. Otherwise, we don't want to use. Okay. Then 14, here 14. So 14 minus 14. So when we talk about this particular decryption process, we are simply subtracting the ciphertext with the key, and if the value is negative, we have to use, otherwise we don't want to use this. Okay, so we have to repeat character by character, like 15, 13. 15 minus 13, it is 2. So 2. And 21 minus 11, it is 10. And 4 minus 4, it is 0. And 5 minus 12, see, again it is negative value. So it is minus 7. Minus 7 plus 26, it is 19. And 17 minus 14, it is 3. And 13 minus 13, it is 0. And 7 minus 11 here, it is minus 4. Minus 4 plus 26, it is 22. It is W. So likewise we have to do. So finally we got the plain text back. This is what called as Vigenère Cipher. So in this Vigenère Cipher, we are doing only one thing is different, that is we are repeating the keyword, because we have to equalize the size of plain text and ciphertext. This is what the difference. So next we will be seeing about one-time pad. Okay, let's see about the introduction of one-time pad cipher. When we talk about one-time pad cipher, it is also one of the important classical encryption technique, which is purely perfect secrecy one when compared with Vigenère Cipher, because in this we are fully taking care of random keys. There is no repetition. So previously we are repeating the 11 keyword again and again till the size of plain text. Here the plain text and the keyword size supposed to be always same, and it is purely random, and it used only one time. So here no repetition is happening. So it is better than Vigenère Cipher. In the encryption part, first of all, we are taking the plain text. The plain text is hello here. And the second step is we are going to generate the random key. The random key size and the plain text size supposed to be same. So here the size of the plain text is 5, and the particular random key also seems to be 5, and it is purely random and should not be repeated, and it is used only once. So here we are taking the keys XMCKL. It is purely random. Now we are applying for encryption part. First of all, we have to convert the letters into numbers. So for each letters, the corresponding values we have to find. Likewise, for plain text as well as key, we have to find. So after that, we have to add. If the value is more than 26, again we have to apply for mod 26. So 7 plus 23 is already, it is 30. 30 mod 26 is 4. So we got E. And 4 plus 12, it is 16, then Q. And 11 plus 2 is 13, N. And for 11 plus 10 is 21, it is V. And for 14 plus 11 is 25, it is Z. So likewise we have to find the corresponding value. So this is called the ciphertext form. Next we have to find the decryption part. So in this decryption part, we have to find the ciphertext minus key. Then if any of the value is minus, we have to apply 26. After that we have to apply for mod 26. As of now, we got the ciphertext is E, Q, N, B and Z. The value for E, Q, N, B, Z is 4, 16, 13, 21, 25. So we have to subtract this with the key. Respective key values are here. So here 4 minus 23, it is minus 19. It's a negative value. So at that time we have to add it. So minus 19 plus 26, it is 7. So 7 is H. And 16 minus 12, it is 4, that is E. And 13 minus 2, it is 11, it is L. Then 21 minus 10, it is 11. And 25 minus 11, it is 14. So finally, we got the plain text back. This is what called as one-time pad. Okay.
Please like and subscribe to my channel and press the bell icon for regular updates. Thank you very much for watching.